Whew. Hey guys, welcome back to AlgoYogi 2.0 series. That's what we are doing right now. Now, what I've decided is I'm just following like this script. But hey guys, welcome back to AlgoYogi and all that shit. I think I'm gonna because my purpose here is to just enjoy doing these problems and not really make some educational content, because I think these problems are not to be taught, by the way. These are to be done. So you should be watching this and like just keep it on the side. But what I really want you guys to do is just open the problem yourself and just go through it, do it yourself. Don't stop watching it. I don't think like it's really helpful. These are not even tutorials. This is, I am like recording my own problem solving basically, and I think you should do it too, because then you're conscious and then you're like really active and you're just thinking out loud and typing the code. Do it many times, and then you get like really comfortable walking through the problem yourself, coming up with these edge cases, and then solution, and then implementation of the solution, and then just time complexity, space complexity analysis. You should have a pattern. I think that's what I am trying to achieve for myself here, and you should do it too. So now let's move on to our next problem, which is for sum. I think I had to say it, but definitely give it a like. That gives me a little validation to keep going, keep recording. All right. For sum, given an array nums of n integers, return an array of all the unique quadruplets. Basically, this like tuples, you can say tuples of 4 different unique integers, that such that this condition satisfies, where basically a, b, c, and d, those are the indices of values in nums. They're in the range. That's not even a condition. They have to be, and they're all distinct. All the indexes, a is not equal to b, is not equal to c, is not equal to d. They're all different indices, and they are all summing up to basically target, right? So we have already done problems like that, 2 sum, 3 sum, and this is what basically maybe the last of this sum problem, for sum. And for like they've given this example here. Basically this is the array and the target is 0, but this time like just like 3 sum here, target is not going to be always 0. Earlier it was. Now so this target differs, right? So what we can do is, what about the brute force approach? What would be a brute force approach? I say you just need to find 4 different indices where values, all those 4 values combine to give you basically the target value. Once you have that, then you basically add it to your result array and then return the result array. But make sure that you go through the entire array and all these different combinations of these values, right? All the permutations of choosing 4 different elements, you can say it like that. So what's going to happen is, in a brute force approach, we can have 4 different 4 nested loops. So I can start here. Let me show it. So I can start over here, j can start over here, like j can start at I plus 1, and k can start at j plus 1. This is 3, and L can start at k plus 1, right? So that we are not like using something again. All the indices are unique. So this is basically a brute force approach. You have 4 loops and you're running over basically all the values of nums, and then you're trying to find if the sum equates to target, then you add it to your result array, and that would be basically that will give you a time complexity of big of n to the power 4, right? So I think we can definitely do better, just like we did better in big of 3 sum. We were able to get it to n square, so I think we can definitely get it down to n cube. Okay, so how can we do that? I say we can use 2 pointers approach. That's what we're going to do. So we basically plug in this, we divide this problem into basically one loop or 2 loops, and then another 2 loops, combine them into just one 2 pointer approach. So you'll have 2 for loops, so for I in range, for j in range, and then here you'll have start and end. That is basically on the remaining array, and this is after sorting this array. Okay, this is after sorting this array. You have this start and end on the remaining array, and then you see if nums I, and then you basically nums I plus nums j, and then nums start and nums basically end. Just ignore bad handwriting, but just think of the logic, how we're going to bring it close to our target. So these 2 will be fixed, but these 2 can move at in big of n time complexity, so that our total time comes down to big of n cube. So what will happen is, we will see if this is equal to the target, then we add it to our result. Otherwise we check if this sum was equal to greater than target. That means we need to bring this end down, and making sure that if it's equal to the value that we have seen before, then bring it more down. We just keep doing that, and we can also bring this forward if the value was smaller, so that if it is sorted array, then starting needs to go ahead, so that you can find a bigger value, so that you can actually basically make sure that the target, the sum basically gets closer to the target. All right, so now we can write down the solution. I think there is not much to go over, I guess, at this point. Okay, so let's write. As I said, I'm gonna be really relaxed. I don't know, I'm not really here to earn revenue or anything from YouTube. I'm just recording my progress. I like being next to camera and do problem solving. Okay, so as I said, let me shift this. Oh, what a nice day. This is so not good that I'm pretending to be chill. I think we need to learn to be chill and relaxed and do these problems, enjoy them. So we'll have result. That's an array. And then we're gonna basically sort nums. So nums dot sort. That's one important thing, right? And then we are going to start for I in range. That will be basically len nums, okay? And it starts at 0. And then for j in range, and that will basically start at I plus 1, by the way, because we don't want j to also use the value that's already been used by ith index. So j will start at I plus 1 and will go up to the end of the num's length. One more thing here is that if I is greater than 0, right, and nums I is equals to nums I plus 1, that's to make sure that I is not same as that has already been seen. I has seen a value that was same as this ith value. So sorry, I minus 1, I meant one value before I. So if this is the case, then you can continue. Okay, same thing we can do over here, same thing we can do for j as well. If j is greater than 0 and j is basically j's value is equal to j minus 1's value, I mean indices, so then you can continue. Okay, otherwise now we start our these pointers, start and end, right? So I'll just call them start and I'll call them end. So start will be basically at j plus 1 and end will be basically length of nums and minus 1, so that the indexes are valid. So what we do here is we're going to have a while loop where we say while start is lesser than end. Okay, well this is you need to bring these closer depending on where your sum lies. So let's also find the sum here. Okay, so let's find the sum here. So sum would be, so I'll call it S, sum would be nums I, nums j, and nums start plus nums end. Okay, sorry, that's it. So if sum is basically we can say if this is greater than target. So if sum is greater than target, that means what? That my end needs to come backward so that you can find a smaller value, this smaller value at the end. So end needs to basically decremented. So we can decrement end so that we can find a smaller value, and sum becomes less so that it can get closer to target or maybe equal to best case. If S is smaller than target, right? So if it is smaller than target, then we need to get to a bigger value, start plus 1, right? Else, what would be else? That means we are equal to target. Our S is equal to target because lesser than or equal to greater than they have been checked. That's the last remaining bit. And if that's the case, I want to append all these values, right? We were asked the values, not the indices that we need to return. So s dot append these values. So they will basically be an array, and let's make them quadruplets. Yeah, I'm just kidding. Okay, now there's one more thing, is we need to basically keep this for efficiency, that if my my start and end, they basically equate to the value that they have seen before or after in terms of start and end. You'll understand what I mean. Then we can keep bringing it down, because we don't want repetitive values, for any of the start or end. I and j have been taken care over here. Okay, they have been taken care. So we need to take care of the start and end. So while while start is lesser than end and nums start is equals to nums start minus 1. Okay, and these will always be valid because start and end always, like, they're starting at later part. So this is one thing that I forgot. So start basically incremented and end is basically decremented. I think now it makes it even more valid, because for end it might not have been valid, but now it will be. So if this is the case, then I wanna take my pointer ahead, keep taking it ahead if the value that current value is basically I would say like equals to or the previous value that I've seen, that I have already used at start as a start index. Okay, while and condition will be same, start is lesser than end and nums end is equals to nums end plus 1. Check before, because we have already decremented it and we have used it. We have used end, we have decremented it. Now we're gonna see if this was equal to the value that we have used. If that's the case, then end minus 1. All right, and I think that's it. That is all. Let's come out of all these too many loops. So now let me zoom out. I think code will be visible. Then we can just return our result. I'm just checking the indentation, and that's it. Let's run it on the examples. Some issue, and what is that? What is it that we haven't taken care of? The second is falling when all the values are same. Expected should have. Oh, okay. Yes, this is the mistake. So what's happening? And this is there was hard to notice. That was because we need to check, see how I can take this I is greater than 0, but j has to take I plus 1. You know why? Because j right now is starting at I plus 1, and then what it will check is if current value that j is pointing to and I is also pointing to the same value, then it will check that j at 1, index 1 minus j minus 1, that will check that they were same value. That means we are not using it, and that's why I think this problem was failing, because if j was here and I was here, j was checking, oh, this is equal to 2, that means I can't use it. No, you can, because these are two separate indexes. Okay, it's about indexes that have to be distinct. Values could be same because they can equate to the sum, okay, when they're added together. So I think now it should run. That was tricky, because it's easy to make mistakes like that. All right, so let's write down the time complexity, big of n cube, okay, and space complexity, I would say if n is the length of, worst case, if n is the length of nums, then it will be n, worst case. But let's say if there were never any quadruplets that were adding up to, so best case it's 1, because your result is just returning empty, you never add it, and these are all pointers that are playing the game. Okay, so that's it. Let's mark this problem solved. Awesome. For some reason this unchecks. I think I gotta fix that issue. Okay. See you guys in the next problem. Bye bye.